Okay, we're going to talk about transformations a little bit more. Talk about parent functions as well. The parent functions are the most basic, just like parents. A little piecewise example there for you. We'll get on with our lesson. Okay, we're going to have a family of functions has graphs that are similar to its parent functions. The most basic parent functions for each are as follows. First one, y equals x. Y equals x is the parent function of a linear equation. So I guess if we're talking functions, we can go ahead and call it f of x equals x. Notice it has a slope of 1 and a y-intercept of 0. Goes through there, and then we could get a few points, and we could make our graph and connect our dots, and we get a linear function. And left and right, we can put anything in there, so it's going to be negative infinity to infinity. Range goes all the way down, goes all the way up. It's a pretty basic deal. Y-intercept or x-intercept is going to be at going to cross the x-intercept at x equals 0, y-intercept at y equals 0 because it goes through the origin. Okay, so the parent function of a linear equation is y equals x. Absolute value, remember the equation of absolute value, 0, 0, 1. This is a linear function going this way, but then when I put negatives in for x, the absolute value makes them positive. I always remember this as it's shaped like a V. The vertex is at 0, 0. My domain, left and right, I can put anything in there. I can put negatives in there. I can put 0 in there. I can put positives in there. Range, how low do we go? The lowest we go on the range is going to be 0, and since I can be 0, remember I put a bracket, and then I go all the way up to infinity. Again, we're at the origin, so the x-intercept is at 0. 0. It's at 0, 0 for both of them, so it doesn't even matter. Okay, so now we've got the square root. Remember, square root has a problem because you can't take the square roots of negatives. So I always remember, like, the square root of 0 is 0, the square root of 1 is 1, but then the square root of 4 is 2, and the square root of 9 is 3. So it is going up as it goes out. So I'm starting at 0, and I'm going to infinity on the left and right. Now the range, my lowest value again is 0. I am going up to infinity. You might think it looks like it's leveling off, but square roots of really huge numbers are really huge numbers. So we do head up as we go out. Okay, again, we're at the origin, so my x-intercepts and y-intercepts are both going to be at 0. Quadratic, y equals x squared. Remember, you're going to have 0 squared is 0, 1 squared is 1, 2 squared is 4. Negative 1 squared is 1, negative 2 squared is 4. That's where we get our parabolic shape. We're going to have a whole fraction based on f of x equals x squared. The domain, left and right, again, negative infinity to infinity, all real numbers. Range, as low as we go, again, is 0. As high as we go is infinity. X and y intercepts are both at the origin. Exponential function, okay, this is going to be 2 to the x, or it's really, oftentimes it's e to the x. It's anything that's not 1 to the x greater than 1 here. 2 raised to the power of 0. So I like to remember this one as it's going through 0, 1. So if you have y equals 2 to the x, or y equals, we do e to the x once we get into calculus. E is just a number, don't worry about it. But 2 to the 0, anything to the power of 0 is 1. And then 2 to the 1 is 2. 2 to the 2 is 4. 2 to the negative 1 is a half. Do you remember that? 2 to the negative 1 is 1 over 2. 2 to the negative 2 is 1 over 2 squared, or 1 over 4. So what I'm going to do is I'm never actually going to get to 0. I'm going to follow an asymptote here. I'm never going to cross over that line that is that asymptote. So my domain, I can put anything in there. I can raise anything to the power of 2 to the any power, 2 to the x. But the range, I never actually get down to 0. So I have a parenthesis there, which is a boundary but not reached. Not reached. The x-intercept, there isn't one. None. There is no x-intercept. Y-intercept is at 1 because it's at 0, 1. Because when x is 0, 2 to the power of 0, anything to the power of 0 is always equal to 1. Rational, a rational. Rational is a fraction. Fraction, 1 over x. Y equals 1 over x, okay? Now, we're not allowed to divide by 0, right? We're not allowed to divide by 0. So that means x can never be 0. So there's an asymptote here, okay? So we never cross the x-axis, so there is no x-intercept. And for that matter, since this be 0, we can never make this be 0 either. So there's an asymptote there. More on asymptotes later in the course. Domain. So if I can never be 0, I start all the way on the left, and I come swinging in all the way to 0. I jump over 0, and then I start coming down over here. And there you have it. Range is exactly the same. Look at how far down we start. We start down all the way down. We come up. We don't ever get to 0. We jump over. We come up. And we keep going up. And there is no y-intercept either. Okay, transformations are just when we're going to move things around. A change in well, size is actually going to be kind of a change in shape, I guess, a little bit. So we've kind of got a V here where we've got the marching band out on the football field or the soccer field, whatever, the pitch. And so we notice we moved everything forward. Everybody moved forward that same little bit. That's called a translation. So you've got translation. You got these. That's going to go, so what you need to write on your translations are left or right, up or down. You translate left or right on a coordinate plane. If you think about where the x-coordinate is, this is the x-coordinate, this is the y-coordinate, or f of x. Left and right is going to be addition and subtraction to the x-coordinate. Up or down would be addition and subtraction to the y-coordinate, which means the entire function. Okay. Reflections over the x-axis are usually going to have to do when we multiply by a negative. So if I was talking about left or right, I guess I would say if I was going to add or subtract some value h to just the x value, up or down means I add or subtract some value k to the entire function. And we'll look at some examples of this. A reflection over the x-axis, so again, that's going to be up or down. That would be we negate the entire function. If I make all the positive y's negative, I'm going to bounce them down. A reflection over the y-axis is when I'm going to go left and right, which means I'm making the x value negative, okay? Horizontal stretch is going to make it wider. So we're going to go, I would rather you think of horizontal stretch as wider. I don't care if you know the difference between horizontal stretch or horizontal oh, it's wider right there. That's this one. And that's going to be when you multiply by like a fraction, okay? We multiply the whole thing by like a fraction. And then down here, we're going to go narrower. We're going to go up faster. So think about slope going up faster. So now I'm going to multiply by a number like greater than. I'm going to multiply by a number greater than 1. And that'll make it go up quicker. So wider and narrower is really, or going up faster or slower. I could call this is going to be a faster or steeper slope. And this is going to be a slower or much more shallower slope. Okay, so a bunch of information there. Let's look at some examples. All right, so I'm just going to go through them one by one. We could take the time and say, hey, check out where you are. I started with the blue one, and I jumped down to the red one. So I was reflected from like this point, got reflected over the x-axis down to here. So reflected in the x-axis, I would say reflected over the x-axis. So I would say reflected, and I would say over the x-axis. Okay, let's see if we can figure out this one. Let's see here. It looks like I started, so these are all, this is the square root of x is the parent function. Oh, they said that over there. And I'm going to go to the left, 1, 2, 3 units. Left 3. So if it's left 3, that's a translation. So when you translate, you just move. I just take my chair and slide her 3 units to the left. And so that's a translation. And I would say 3 left. That's fine. Okay, I'm not sure about that one. Let's go do some of these easy ones first, because I've already done reflected, the x-axis. Okay, and I moved up 2. Well, that's a translated up 2. So we say translated, and it's up 2. I don't know about that one either. And this one, like this point over here bounced over there, this point bounced over there. So I would say reflected over the y-axis, reflected over the y-axis. Okay, and my only 2 left are stretched horizontally or compressed horizontally. And I would say instead of using those terms, let's look at them as, am I going up faster or steeper? And I'm going to say, or narrower. So I'm going to say this one's going to go up faster. It's going to be steeper. So it's probably multiplied by something like, I don't know, 2 times the square root of x, because that's a number greater than 0. That's what you're kind of looking for. And then this one I would say would be slower or wider. And that's going to be like y equals 1/2 the square root of x. We multiply by a number less than 1. Okay. All right, let's see what's next. All of it together using A, H, and K. All right, so A is the same A from the standard form of an equation, ax plus by equals c. This is going to be up or down. This is for an absolute value one. This is for the radical square root. This is for a quadratic. We'll have a whole chapter on that. This is for a rational. So the A has to do with, for all of them, it has to do, if A is greater than 0, then it's going to go up. It's going to be faster, greater than 1. I should have said greater than 1. Almost made my first mistake of the year. Faster or steeper. It's going to go quick. Think about slope of a line. If A is greater than 0 and less than 1, that's a fraction. It's going to go slower, or it's going to be wider, okay? If A is less than 0, that means it's negative, then it's going to be reflected over the x-axis. Reflected over x-axis. H, for all of them, H, it's going to be left-right. Please note, H is kind of an opposite idea. The minus is in the formula. You gotta watch out for that. That's left or right, and K is up or down. So the biggest thing, if you're not paying attention today, pay attention right now. Because x minus the value of h. So if it's x minus 2, it's actually right 2. If it's x plus 2, it's actually left 2, and that can be a little bit confusing. Okay, find the values of h and k. So I would go left 2, up 1. So if I went left 2, up 1. Left 2 means h is negative 2. This is terrible. H equals negative 2. K equals positive 1. The formula for this one would be y equals absolute value of x minus negative 2. X minus negative is x plus 2 plus 1. You got to be careful on that. X minus h plus k. That's x minus negative 2. It went left 2, up 1. Over here we have a radical. Looks like I went 1, 2, 3 to the right, 1, 2, 3, 4 down. Right 3. That means h is positive 3. Down 4 means k is negative 4. Y equals the square root of x minus the value of h. Oh, that should be a 3. X minus 3, and then minus 4. So that one was y equals the square root of x minus 3 minus 4. This is 3 right. Don't get caught by that, and that's 4 down. 1, 2, 3, 4 left. I can't get it. 4 left and 1 up. 4 left, that means that h is negative 4, k is positive 1. Y equals x minus negative 4. Minus negative means plus. Plus 1. This is 4 left, that's 1 up. This is x cubed. We didn't talk about x cubed, but it's the same thing, and I went 2 right. 2 right means 2 right means that h is 2. Y equals x minus 2 cubed. Remember, x minus the value of h, which is positive 2, 2 units to the right. That's it. Have a great day.